A dead star smaller than a city is spinning so fast that its surface moves at nearly a quarter of the speed of light. If it rotated any faster, scientists believe it could literally tear itself apart. Somewhere in deep space, this object flashes powerful beams of radiation toward Earth more than 700 times every single second. The fastest known pulsar ever discovered is called PSRJ 1748, 2446 AD. It spins at an almost unbelievable speed of 716 rotations per second. That means in the time it takes you to blink once, this object can rotate thousands of times. To understand how insane that is, imagine the entire mass of the Sun crushed into a sphere only about 20 kilometers wide. Then spin it faster than the blades of any machine humans have ever built. That is a pulsar. A pulsar is a special type of neutron star, the collapsed core left behind after a massive star explodes in a supernova. When these giant stars die, gravity crushes their cores so violently that protons and electrons merge into neutrons. The result is one of the densest objects in the universe. Just 1 teaspoon of neutron star material would weigh billions of tons on Earth. But pulsars are not just dense. They are cosmic lighthouses. As they spin, they emit narrow beams of electromagnetic radiation from their magnetic poles. If those beams sweep across Earth, astronomers detect rapid pulses of radio waves, X-rays, or gamma rays. That is why they are called pulsars. The strange thing is that pulsars are incredibly accurate. Some rotate with such precision that they rival atomic clocks. Scientists actually use certain pulsars to search for gravitational waves and study distortions in space-time itself. But PSRJ 1748, 2446 AD exists in an entirely different category. Discovered in 2004 by astronomers using the Green Bank telescope in West Virginia, this pulsar is located about 18,000 light-years away inside the globular cluster Tirzan 5 in the constellation Sagittarius. What makes it extraordinary is not just its speed, but the physics required for something that massive to spin so fast without breaking apart. The pulsar likely became this fast by stealing matter from a nearby companion star. As gas from the companion spiraled inward, it transferred angular momentum to the neutron star, gradually spinning it up over millions of years. Scientists sometimes call these objects millisecond pulsars because each rotation takes only a few milliseconds. PSRJ 1748, 2446 AD completes one full rotation in just 1.39 milliseconds. That speed pushes the known limits of neutron star physics. Researchers believe there is a theoretical maximum speed for neutron stars. Beyond that point, centrifugal force could overcome gravity, causing the star to lose material or collapse into something even stranger, possibly a black hole. And yet this pulsar is dangerously close to that limit. The magnetic field around such an object is also extreme. Pulsars can produce magnetic fields trillions of times stronger than Earth's. Near the surface, the environment becomes so violent that atoms themselves can be distorted by the magnetic forces. If a human somehow got close to a pulsar, the radiation alone would be instantly fatal long before gravity became the problem. And gravity is another nightmare entirely. A neutron star packs more mass than the Sun into a sphere barely wider than a city. The gravitational pull is so intense that if you dropped onto its surface from even a tiny height, the impact energy would equal a nuclear explosion. But the universe may contain even stranger pulsars. Scientists have discovered pulsars that suddenly glitch and change speed without warning. Others emit mysterious bursts of energy that researchers still cannot fully explain. In recent years, astronomers also linked some neutron stars to fast radio bursts, extremely powerful flashes of radio energy coming from distant galaxies. These discoveries are forcing scientists to rethink what neutron stars are truly capable of. And there is another terrifying possibility. Some pulsars spin so consistently that astronomers think advanced civilizations could theoretically use them as natural navigation beacons across the galaxy. NASA has even explored using pulsars as a kind of cosmic GPS system for future deep space spacecraft. That means these dead stars may someday help humanity travel far beyond the solar system. But despite decades of research, scientists still do not fully understand what matter becomes inside neutron stars. The pressures are so extreme that entirely new forms of matter may exist there, matter humans have never observed anywhere else in the universe. So hidden inside the fastest pulsar ever discovered may be physics that could completely change our understanding of reality itself. A star died, collapsed into something smaller than a city, and became one of the fastest spinning objects ever known. And somewhere out there, an even faster pulsar may already exist, waiting to be discovered. Follow for more terrifying mysteries hidden in space. If humans ever learned how to harness the energy of a pulsar, would it become the greatest technological breakthrough in history or something far too dangerous to control?